For years, the story of AI has been dominated by a single name, Nvidia. They didn't just build chips, they built an entire empire around CUDA, a software ecosystem so powerful it became the de facto language of artificial intelligence. The assumption, almost a universal law in tech, was that American silicon innovation held a multi-year, unassailable lead. Imagine a world-class orchestra, finely tuned, playing a complex symphony that's been the Western tech stack. Every note, every instrument perfectly coordinated. The rest of the world, especially for cutting-edge AI, seemed relegated to playing catch-up, relying on architectures designed and perfected thousands of miles away. It felt like a settled score, a technological monarchy with an uncontested crown. But beneath this surface of calm dominance, something fundamental was shifting, quietly challenging the very premise of this global reliance. The relentless march of AI isn't just about faster chips. It's about an insatiable hunger for compute, a demand that has seen processing requirements doubling every few months. This geometric growth pushes against fundamental limits. We're talking about the physical constraints of silicon manufacturing and the sheer impossibility of powering data centers that continue to balloon in size. Imagine trying to power a small city purely to run algorithms. That's the scale we're approaching. Data centers, the hidden engines of the digital world, are quietly groaning under this stress. Current designs are rife with inefficiencies, consuming staggering amounts of energy, not just for computation, but for cooling and simply moving data around. The math behind simply scaling up existing solutions doesn't add up. It's a challenge that threatens to slow the entire AI revolution, a bottleneck waiting to snap. So, instead of merely chasing raw chip speed, some players began to look at the entire system from the ground up. While much of the world fixated on Nvidia's quarterly announcements, a different narrative was unfolding, quietly but with immense strategic intent. Huawei, long known for its telecoms infrastructure, has been executing an ambitious roadmap for its Ascend AI processors, one laid out years in advance. Vice President Chen Lin publicly declared a commitment to doubling compute power annually with each new Ascend generation, a pace that seems almost unbelievable to those accustomed to incremental gains. This wasn't just a promise. It was backed by proprietary architectural innovations like the Tau scaling law and logic folding, fundamental redesigns to how AI computations are organized and processed. The 2026-2028 roadmap isn't just about faster chips. It's about establishing an independent, end-to-end AI ecosystem capable of keeping pace with the world's most advanced designs. For years, the sheer numerical advantage of Nvidia's silicon was undeniable, creating a seemingly insurmountable gap. But quietly in the background, Huawei was preparing its counter-argument. On March 21, 2026, the Ascend 95PR formally launched, and with it, a new benchmark for domestic AI compute emerged. This wasn't just another chip, it was an entire processing architecture capable of 1.56 pflops in FP4. To put that into perspective, independent measurements indicated it was 2.8 times faster than the Nvidia H200 available in China. Imagine a specialized engine designed for one purpose: AI, meticulously engineered not just for raw speed, but for memory efficiency. The Ascend 9550 UPR packs 112 gigabytes of high-BL memory, capable of a staggering 1.4 terabyte SAN bandwidth, creating a balanced and formidable system that directly challenges the perceived limits of what was possible outside the dominant players. For years, the sheer numerical advantage of Nvidia's processing power captured all headlines, creating a seemingly insurmountable gap. But the chip alone is only half the story. An AI processor is only as good as its memory subsystem. And this is where Huawei is executing a silent yet profound shift. The upcoming Ascend 950 DT, slated for Q4 2026, isn't just about raw compute. It's designed specifically for the memory-hungry tasks of AI training and decoding. It integrates Huawei's proprietary HiZQ 2.0 HBM memory, a crucial development that quietly redefines the balance of power. We're talking about a massive 144 gigabytes of memory with an astonishing 4 terabytes per second of bandwidth, addressing one of the most critical bottlenecks in advanced AI workloads. This isn't just an upgrade, it's a strategic declaration. For years, the sheer challenge of manufacturing cutting-edge silicon at scale was seen as China's Achilles heel, an insurmountable barrier to true AI autonomy. But Huawei, in partnership with SMIC, is directly addressing this with aggressive, concrete targets. The plan for 2026 isn't just an incremental step. It's a bold declaration. 600,000 Ascend 910C chips will be shipped, a figure that precisely doubles their 2025 output. This ambitious goal suggests a much broader strategy than mere market capture. Across the entire Ascend line, the aspiration is to hit 1.6 million units of crystal production, leveraging SMIC's enhanced 7-nanometer process. It's like attempting to build an entire city in a year, with tools previously deemed too rudimentary for such scale. This isn't just about designing a powerful chip. It's about proving the capacity to mass-produce it, demonstrating an industrial resilience few outside of China believed possible. The math was impossible, until it wasn't. For years, the sheer numerical gap between Chinese AI hardware and its global competitors felt insurmountable, often cited as a 5-year chasm. But in mid-2026, Huawei made a declaration that fundamentally shifted the timeline. Their roadmap for the Ascend line isn't merely about incremental improvements. It's an aggressive play for performance parity. The Ascend 960, slated for a 2027 release, is explicitly targeting performance equivalent to Nvidia's Blackwell architecture, which is still rolling out today. This isn't a wishful projection, but a core strategic pillar where each subsequent generation, including the 970 in 2028, promises a doubling of computational power, memory capacity, and interconnect bandwidth. If Huawei hits this target, that 5-year lead shrinks to roughly 2. This means the future of AI supremacy won't be about who's first, but who can sustain that rate of acceleration. For all its raw processing capability, Huawei's Ascend 950R arrives with a notable asterisk. This chip at peak operation consumes 600 watts of power. That's 200 watts more than Nvidia's H20. In the abstract, this might seem like a minor detail, but scale it up to a data center with thousands of these processors, and the implications become profound. Imagine a massive building running at capacity. Every additional watt translates directly into increased electricity bills, more robust cooling infrastructure, and ultimately, a higher total cost of ownership. It's a fundamental paradox. Immense power demanding immense power, challenging the very economics of deployment. Right now, this reality means that while the Ascend 950PR is highly capable, particularly for inference tasks where its speed gains shine, its suitability for the most demanding, continuous training workloads is still being actively debated within the industry. For years, Nvidia's dominance wasn't just about the raw power of its chips, but the pervasive gravitational pull of its CUDA software ecosystem. Developers, researchers, and entire industries were locked into a proprietary world. Huawei, however, wasn't just building chips. They were playing a much longer game, specifically designed to dismantle this lock-in. Quietly, they announced plans to open-source the entire Ascend platform, including their CAN development toolkit, the Mind AI framework, and even core Pangu models. As Huawei chairman Eric Xu put it, they were directly addressing the ecosystem problem head-on. It's an aggressive countermove, an attempt to build a parallel universe where open standards, rather than proprietary control, define the future of AI development. Instead of simply building an alternative chip, they're attempting to build an alternative internet for AI, one where developers aren't beholden to a single gatekeeper. For years, the sheer challenge of scaling AI compute beyond individual servers seemed like a problem of distributed physics. Coordinating thousands of discrete processors, each with its own memory, meant a constant battle against latency and bandwidth bottlenecks. But then came July 2026 and the World AI Conference in Shanghai. Huawei didn't just announce another chip. They unveiled the announced 950 SuperPOD. This wasn't merely a collection of powerful machines. It was presented as the industry's largest supernode capable of unifying vast amounts of memory across an entire system, treating it like a single massive pool. It's an audacious move, targeting the very frontier of AI development. training and inference for models with trillions of parameters, a scale previously considered impractical. It's an architecture designed to untangle the Gordian knot of distributed computing, not with faster individual threads, but with a fundamentally different fabric. This technological ascent, whether reaching full parity or not, carries implications far beyond corporate balance sheets. For years, the narrative around U.S. tech sanctions on China was one of crippling dependence, a strategic chokehold designed to stall the nation's ambitions in critical fields like AI. Now, however, the very existence of chips like the Ascend 950PR and its successors acts as a powerful counter-narrative, forcing a fundamental reevaluation of those export controls. The push for self-sufficiency, once viewed as an aspirational goal, is visibly translating into tangible hardware. This doesn't just reshape supply chains. It accelerates the fracturing of a singular global tech infrastructure into distinct parallel ecosystems, particularly for AI. Instead of asking how to contain, the question becomes how to navigate a world where foundational technologies are no longer unilaterally controlled. The quiet confidence emanating from Huawei isn't just about catching up. It's about fundamentally altering the gravitational pull of the AI hardware universe. Their public commitment to a new Ascend generation every single year, each doubling in raw compute power, memory, and interconnect bandwidth, paints a picture of relentless, structured progress. This isn't merely incremental improvement. It's a strategic long game, designed to create an alternative center of gravity for AI development. Suddenly, the 5-year gap to Nvidia's architecture isn't an immutable law, but a challenge that could be halved, then closed, within just a few product cycles. The competitive landscape shifts from a chase to a parallel race, where foundational AI infrastructure becomes the new pivotal battleground. Instead of asking if China can replace Nvidia's chips, the question becomes, how quickly can China establish a self-sufficient ecosystem that reshapes the very definition of AI leadership? The long-term implication isn't just about market share, but about who defines the next era of artificial intelligence itself.